Alright, so the second thing you need to know is reactivity of the leaving group. This by far is probably the most important thing you have to understand for nucleophilic acyl substitution reactions. You understand this concept, you understand the substitution reaction. So let's get started. On the right, we got acid halides. On the left, least reactive, amides. So why? Did someone just arbitrarily choose this? Well, if you think about it, using your chemistry logic, you find that, chlorine, or any type of halide for that matter, they're really electronegative, meaning they're really greedy people. They just keep taking electrons away from this poor carbonyl group. As opposed to amides, they're friendly, they're easygoing, they got a lot of electrons to give away, they got a lot of cash, they got dough, they can spend it, they can share with this carbonyl group. And that determines the reactivity. There's actually another way to explain this though. If you look at the leaving group, you want to determine a leaving group that's most stable when you bump it off. Because you got your leaving, it's called a leaving group for a reason. It's going to leave. And when it leaves, it wants to be stable. So how do I explain this in English? How do you visualize this in the real world? Well, put it this way. Chlorine is like a university student. He's ready to leave. He wants to get out of the house, he wants to go to residence, he wants to have a lot of fun, and he's greedy, university students. As opposed to, this amide group here, he's like a 5-year-old kid, okay? So, what do you think is going to be a better leaving group? 5-year-old kid or university student?